The universe was not born gently. It exploded into existence in a fury of energy and light. Imagine, if you will, a point of infinite density, smaller than the smallest atom yet containing the potential for everything we see around us. This was the singularity. Then, in a fraction of a second, it erupted. This was the Big Bang. Time itself began. Space expanded at an unimaginable rate. The universe was a maelstrom of extreme heat and unimaginable violence. Within this chaotic inferno, a battle of cosmic importance raged. Matter, the stuff of stars and galaxies, clashed with its nemesis, antimatter. For every particle of matter there existed an antiparticle. These were mirror images, equal but opposite. When they met, they annihilated each other in a burst of pure energy. It was a cosmic dance of creation and destruction. The very existence of the universe hung in the balance. In this primordial soup of particles, something astonishing happened. A slight imbalance, a tiny surplus of matter over antimatter emerged. For every billion particles of antimatter there were 1,000,001 particles of matter. This seemingly insignificant difference was profound. As the universe cooled and expanded, matter and antimatter continued their deadly dance. But that tiny excess of matter meant that it wouldn't be a perfect tie. Eventually all the antimatter was consumed, leaving behind a universe dominated by matter. The universe cooled. The energy of the Big Bang condensed into particles. Quarks combined to form protons and neutrons, the building blocks of atoms. Still, the universe was a far cry from the magnificent tapestry of stars and galaxies we see today. It was a dark, hot fog of hydrogen and helium, the simplest elements in the universe. For millions of years, darkness reigned. Gravity, the architect of the cosmos, began to exert its influence. It drew together clumps of hydrogen and helium. These clumps grew denser, their cores compressed under immense pressure. Temperatures soared. Then, in a spectacular display of cosmic fireworks, the first stars ignited. These weren't like the stars we see today. They were colossal, hundreds of times larger than our sun. They blazed with a ferocity that is hard to fathom, fueled by the primordial hydrogen and helium that surrounded them. But these stellar pioneers lived fast and died young. They consumed their fuel at a prodigious rate. Their cores became furnaces where nuclear fusion forged heavier elements, carbon, oxygen, nitrogen. These were the seeds of life itself. Then, in a final glorious act of self-destruction, these stars exploded as supernovae. They scattered the newly forged elements far and wide, enriching the cosmos with the ingredients for planets and eventually, life. The death throes of the first stars marked a turning point in the universe's history. The scattered remnants of these explosions, enriched with heavy elements, became the building blocks for a new generation of stars and, even more remarkably, galaxies. Gravity, the invisible hand guiding the cosmic symphony, began to sculpt vast clouds of gas and dust. These clouds, colossal in scale, were drawn together by their own gravity. As they contracted, they began to spin. Within these swirling clouds, regions of higher density formed. These were the seeds of galaxies, each destined to become an island universe of billions, even trillions of stars. Our own galaxy, the Milky Way, emerged from this chaotic dance. A magnificent barred spiral, it's just one of billions of galaxies that populate the observable universe. Each galaxy a testament to the power of gravity to create order from chaos. Section 5. A Cosmic Cradle. The Birth of Our Sun and Earth. Within the Milky Way, about 5 billion years ago, a remarkable event occurred. A cloud of gas and dust, enriched with the remnants of countless supernovae, began to collapse. At the heart of this collapsing cloud, a star was born, our sun. The nascent sun's gravity drew in the remaining material, forming a swirling disk of gas and dust around it. Within this disk, dust grains, drawn together by electrostatic forces, clumped together. These clumps, over millions of years, grew into planetesimals, the building blocks of planets. One of these planetesimals, orbiting the sun at just the right distance, would eventually become our home, the Earth. As the Earth grew, its gravity attracted more and more material. It heated up, its interior melting. Heavier elements sank to the core, while lighter elements rose to the surface. The Earth was a dynamic, evolving world. Section 6. The Expanding Universe. A Journey into the Unknown. As our solar system was taking shape, astronomers began to make astounding discoveries. Edwin Hubble, observing distant galaxies, noticed something peculiar. The light from these galaxies was stretched. Its wavelength shifted towards the red end of the spectrum. This redshift, Hubble realized, could only mean one thing. The universe was expanding. Imagine baking a loaf of raisin bread. As the dough rises, the raisins embedded within it move farther apart. Similarly, the galaxies are not flying through space but are carried along by the expansion of space itself. This discovery revolutionized our understanding of the universe. The universe, far from being static and eternal, was dynamic, evolving, and expanding. But what was driving this expansion? What was the ultimate fate of the universe? These questions continue to captivate astronomers today. Section 7. The Fate of the Cosmos. A Glimpse into Eternity. The fate of the universe is a question that has intrigued astronomers and philosophers alike for centuries. Will the universe continue to expand forever, growing colder and darker with time? Or will gravity eventually halt the expansion, pulling everything back together in a cataclysmic big crunch? The answer, it seems, depends on a mysterious force known as dark energy. This enigmatic force, which makes up roughly 70% of the energy density of the universe, is counteracting gravity, pushing the universe apart at an accelerating rate. If dark energy continues to dominate, the universe is headed for a big freeze. Galaxies will drift farther and farther apart, their light red-shifted into oblivion. Stars will eventually exhaust their fuel and die out, leaving the universe a dark, cold, and desolate place. But even in this bleak future, the laws of physics, the fundamental constants of nature, will continue to hold sway. Section 8. A Universe of Wonders, Our Place in the Grand Scheme. As we contemplate the vastness of the cosmos and the unimaginable scales of time and space, it's humbling to consider our place in it all. We are, after all, just a tiny speck of life on a small planet orbiting an ordinary star in a vast and ancient universe. Yet we are also a product of this universe, forged from the ashes of dead stars. Our very existence a testament to the intricate chain of events that led to our being here. We are the universe becoming aware of itself, capable of contemplating its own origins and destiny. This cosmic perspective should fill us with a sense of awe and wonder. It should also inspire us to learn more about our universe, to explore its mysteries, and to unravel its secrets. We are, after all, the universe's way of experiencing itself. Section 9. The Cosmic Perspective. A Call to Humility and Curiosity. The study of the universe has a profound impact on our understanding of ourselves and our place in the cosmos. It teaches us humility, reminding us that we are but a small part of something much grander than ourselves. It also ignites our curiosity, urging us to explore the unknown, to seek answers to the big questions that have captivated humanity for millennia. The cosmic perspective can be a source of comfort and inspiration. It reminds us that our problems, while seemingly insurmountable at times, are often insignificant on the grand scale of the universe. It also encourages us to cherish our time on this planet, to appreciate its beauty and fragility, and to protect it for future generations. The universe is vast and mysterious, full of wonders yet to be discovered. It's a universe that invites exploration, that beckons us to push the boundaries of knowledge, to venture beyond the familiar, and to embrace the unknown. Section 10. Our Cosmic Legacy. A Time for Exploration and Discovery. We live in a remarkable time, a time when we have the ability to explore the universe and unravel its mysteries like never before. We have sent probes to the outer reaches of our solar system, landed rovers on Mars, and captured images of distant galaxies billions of light-years away. But our journey of discovery has just begun. We are on the verge of even more astounding breakthroughs, from detecting gravitational waves to unlocking the secrets of dark matter and dark energy. The future of space exploration is bright, filled with promise and potential. This is our time to explore, to discover, and to leave our mark on the universe. Let us use this time wisely to advance our understanding of the cosmos and to inspire future generations to continue our journey of exploration and discovery. The universe awaits.